How did I compile this review together? This is the first time I've done this. I looked at the ACT standards, and I said if people wanted to score somewhere between a 20 and a 32, which is the majority of people in this class, you would score between a 20 and a 32, that these are the types of problems that they would expect that you would be able to do. Now, some of you may say some of this material I saw back in 7th grade. Actually, the math portion, the ACT, the majority of the content is from your 7th, 8th, 9th, and 10th grade years. Very little of it is from this year, okay? The stuff that you get this year is really the stuff that would carry you from like a 30 to a 36. So you may not remember some of it because we all retain mathematics differently. Some of you forget it easily, some of you remember it well. So here we go. Number and quantity. The first sets that we go through are dealing with different types of numbers and operations. Ordering of decimals and ordering of fractions. Order from least to greatest. The smallest number here is going to be this guy right there. So 0.001 is less than, and the next one is going to be this guy, 0.101, followed by 0.11, followed by 1.01. And many of you say, that's not a big deal, I get the decimals piece. Well, how about the fractions? Which one is the smallest there? Which one is the smallest? Yeah, because this is 1 and 1 over 99, right? So if you change it to a mixed number, so this is 1 over 2, 1 and 1 over 8, 1 and 1 over 4. You can see they're all 1 point something, but it's going to be 100 over 99. That's the smallest. And the next smallest could be 9 over 8, and then it's going to be 5 over 4, and it's going to be 3 over 2. 25%, 1/5, and 0.3. Which one's the smallest there? Because 1/5 is the same as 2/10 or 0.2. So 1/5 is 0.2, so that's the smallest. Followed by 25%, because 25% is 0.25. Followed by 0.30. They may look simple, but I've had many students in this class get these problems wrong that we're reviewing. We want to make sure you get the easy ones right. Which one is the smallest here? Square root of 7 is between what two values? 2 and 3, because the square root of 4 is 2, and the square root of 9 is 3. So square root of 7 must be between 2 and 3. So the smallest value is going to be 5 over 3 because that's 1 and 2/3. So 5 over 3 is the smallest. That is going to be less than the square root of 7, which is less than 3 and 1/3. This is a basic example of number and quantity. Another piece of number and quantity is going to be adding your matrices. I don't know if you remember matrices operations, but if you're adding them, it's very simple. This is a 3 by 2 matrix, and you're adding it to another 3 by 2 matrix. That will produce a third 3 by 2 matrix. Matrices must be the same size if you add them together. Simply add corresponding entries. We get 6, 2, 2, 4, 2, 5. You may be asked to multiply by a scalar in order to create a new matrix. So 5 times the quantity 1, 0, negative 4. That simply produces another 3 by 1 matrix, which is going to be 5, 0, negative 20. If you see a matrix question on test, it may look complicated. The fact is they should be pretty straightforward and easy. Multiplying matrices will be where it will be most challenging. Who could tell me the size of this matrix? 1 by 3, rows by columns. How about the size of this one? 3 by 2. The middle numbers tell you that they are compatible. The outside numbers tell you the size of the new matrix. So we get a 1 by 2, 1 row by 2 columns. We're simply going to have 2 entries. The way that we multiply matrices is we take the row and we place it on the column. and we multiply. 1 times 3 is 3. 0 times negative 1 is 0. 2 times 0 is 0. So therefore, that first entry will simply be 3. The second entry, I take the row times the column. 1 times 0 is 0. 0 times 1 is 0. 2 times 4 is 8. 3, 8. Along with number and quantity, complex numbers. How do I add complex numbers? I have a real part and imaginary part. You may know what the real part is going to be here. 7. And the imaginary part is simply plus I. Simply join the like terms together, and that's how you add them. Multiply complex numbers. 2 times negative 7 is negative 14, and then I times I is I squared. What is I squared? Negative 1 times negative 14 is positive 14. Negative 4 divided by I. Suppose I have an I in the denominator. What do? Good. I multiply top and bottom by I. That will give me negative 4I over I squared. Again, what is I squared? And negative 4I divided by negative 1 will give me positive 4I. Let's look at one that seems very complicated, I to the 51st power. I don't want to multiply that out 51 times. So I'm going to rewrite it. I'm going to rewrite it as I to the 50th times I. Everybody okay with that expression? Now I'm going to take that I to the 50th, and I'm going to rewrite it as I squared to the 25th. Once I get an I squared, I'm good to go, because I squared is negative 1. And negative 1 times I is negative I. You can do it. Come on. Yes. Go. Smartboard, stop being stupid. There we go. Locating square roots on a number line. Square root of 7 is between what two integers? 2 and 3. Square root of 63 is between what two integers? 7 and 8. Knowing that approximation is helpful, folks. Just knowing that it's further to one side than the other. Applying properties of exponents. 64 to the 1/2 power. What does that mean, 64 to the 1/2 power? What are we saying when we take something to the 1/2 power? Square root. So 64 square root, 8. How about if it's to the 2/3? If I want to write that as a radical, what would that look like? 8 to the 2/3. Cubed root of 8 squared. Nice thing is you can apply these in either order. You can either take the cubed root of 8 and then square it, or you can square 8 and then take the cubed root. Most people square 8 to get 64. Cubed root is 4. And if you write it, again, 9 to the a over b, that would be b roots of 9 to the a power. So the a stays with the base, whereas b becomes the index for the radical. I made homemade pizza this weekend. It was really good. I love Canadian bacon. Anybody else there? Yeah, okay. Carter, you got me. Thank you. Recipe for pizza requires 5 cups of flour, makes 4 small pizzas. How many cups of flour should be used if 7 small pizzas are desired? I guarantee you're going to have a question like this on the ACT. Take 30 seconds, try to set up anything, see what you got. Go. Just about every practice ACT that I go through leads me to at least 2 or 3 proportions. And I try to make it very simple. Cups divided by pizza. I always set up 2 variables right away. The number of cups is 5, and it makes 4 small pizzas. That's going to be equal to a certain number of pizzas divided by, a certain number of cups divided by 7 pizzas. So notice pizzas go on the bottom, cups goes on the top. If you flipped it, that's fine. I cross multiply and solve. I get 35 is equal to 4x divided by 4. 35 divided by 4, let's see, 4 goes into 35 8 times. Leave me with 3/4. So 8 3/4 cups of flour. John pays $25 for his meal. He desires to leave a 15% tip. What is the total expense for his meal? What if he left a 10% tip? What would the tip be? $2.50. What if he left a 5% tip? That would be half of the 10, right? Which would be 1.25. So if you add those together, you get the 15% tip, which is $3.75. You guys go out to eat with Grandma and Grandpa sometime, and they leave a 15% tip, and they calculate it without a calculator. And you're like, how did you do that? And well, that's how they do that. They find the 10, and they find the 5, and they add them together. So that means the total meal is going to be exactly $28.75. You could just multiply on your calculator as well. If it said 15%, go ahead, turn your calculator on, take 0.15 and multiply that by 25. You can see you get the 375. So if it said 18% tip, go ahead and multiply. Okay, flip it over. A coat that was $62 is marked down 20%. What is the cost of the coat after the markdown? So if it's marked down 20%, what percent remains? 80%. So the coat is 80% of its original value. 80% of its original value. Okay, so we're going to find out 80% of 62. And we get $49.60. Now I did that differently first hour. First hour I said, okay, 20% of 62 is going to be $12.40. And I subtracted that from the top. But I want you to understand this idea of, they say mark down 20%, so that means that 80% is what its value is. You try the next one on your own, it's slightly different. Coat is marked down 40% to $80. So what was the original cost of the coat? A little bit different situation. P-score. I like to try to set up an equation. If it's marked down 40%, what percent remains? So 60%, so 0.6 times the original price is equal to $80. You see my equation? 60% of the original price is equal to 80. How would I solve that equation? I would divide both sides by 0.6. You take 80 and divide it by 0.6, you can see you get $133.33. And there you have it. Let's translate some words into, or symbols into words, or words into symbols, excuse me. A product of 9 and x is simply going to be 9x. How about the difference of x from y? What's that going to look like? Difference of x from y. Very good. From y means we take y minus x. We take the x from the y. So important that you see that. 22 less than w. W minus 22. And the quotient of 9 and the sum of x and y. What does quotient mean? Divide. So 9 divided by the sum of x and y. There we have it. Don walks dogs. It's a good job. I would enjoy that. You like dogs? He receives $5 for the first 10 minutes, $2 for each 10 minutes after that. He received a total of 17 bucks. How much time did he spend walking the dog? Go ahead, take 30 seconds, see if you can figure that one out. Okay, you can see that if you take the 5 and add 2 and 2 and 2 and 2 and 2 and 2, see that's 9, 11, 13, 15. Wait, 9? No, there we go. 9, 11, 13, 15, 17. There we have it. Is that what you guys did? So 10 minutes, 1, 2, 3, 4, 5, 6, 7 times, so 70 minutes. Great advice I got from a professor one time was if you don't know how to do the problem, just do the problem. Take the 5 and add 2's until you get to 17. If you want to set up mathematically, you could say 2 times x plus the original 5 is equal to 17. When you solve that, you get x is 6. But then you have to interpret what 6 is. 6 is the number of 2-minute segments, or of 10-minute segments. Add that to the first one, so you still have to figure that out. So sometimes the mathematics that we teach isn't always the best way to solve it. Evaluate the algebraic expression. Please do this one on your own and write the final answer as a fraction. Write the final answer as 1 fraction. Go ahead and take about 40 seconds to do that. 60 problems on the ACT. In the math section, you get 60 minutes. Seniors, if you do finish up some of your work on your mathematics profile, please be sure to then bring some other work during other days.
How long are we doing this for then?
Looks like we take 3 times negative 2 divided by, we have 3 squared minus negative 2 to the 3rd power minus negative 2. So on top you should have a negative 6. And on bottom you have 27, 9, excuse me. 3 squared is 9, and then we are going to add, because negative 2 cubed is negative 8, minus the negative 8 is going to be plus 8, so you get 17 in the denominator. You're going to add 2 to that. So negative 6 over 17 plus 34 over 17. If you find common denominators, so we get 28 over 17 should be your final result. 28/17. Okay, so that kind of takes care of some of our numerical work. We move on to our algebra and functions realm, which is the largest section of the ACT. You should be able to handle simple algebraic operations, such as combining like terms. Negative z and negative 4z make negative 5z, and 1 and 1 make 2. If you subtract, make sure that you distribute the subtraction sign. So we have 3w minus 4y minus y plus 2w. Like terms are 3w and 2w, which make 5w. It's minus a 5y. How do I do 3x minus 2y quantity squared? Very good. Squaring means that I take it and multiply it by itself. So 3x minus 2y times 3x minus 2y. So we distribute to each term. 3x times 3x is 9x squared. And then you have negative 6xy twice. So you get negative 12xy. Then negative 2y times negative 2y is positive 4y squared. I would say 20% of students in this class get that one wrong. Okay. Trust me, all the problems we're going over, these are ones that we see people get wrong considerably. So I want to make sure you guys are getting the basics correct. How would you do this one? Just tell me the approach. We're not going to actually do it. You distribute the 2x through. And after you distribute the 2x through, then you distribute the negative 1 through. So whenever you see polynomials multiplied by each other, just take each term and multiply by each term. First hour really struggled with this one. What if we divide? I don't like to divide polynomials the normal way. I do a different way. What do I use? I like your thought. Unfortunately, it won't help us with the polynomial. It starts with S. It rhymes with synthetic. Synthetic division. Very good. Way to go. Do you know what number I put over here for synthetic division? I put the solution of this, which is 1. Or what numbers I put across the top? Very good. Got that 0 in there because we have 0x squared. Do you remember my first step? I drop this 1, and then I multiply and add. Multiply, add. Multiply, add. Notice your result is positive x squared plus x minus 3. That's what we get. You try the next one on your own. This is one that is commonly done incorrectly. Aaron, what profession did you choose? Commercial airplane pilot. I like it. Very good. It's not on there, but you're researching it anyway. Good for you. Wow. Go get her. Extra credit for you. Grace, what did you choose?
What I want to do or what's on the list?
What's one that you chose on the list?
Forensic analysis.
Oh, cool. All right. So you're going to solve crimes. Yep. Way to go. Thanks for making our community safer. 2x times this thing. So I got 2x times. I can take that to the 4th power. 3 to the 4th should be 81. X to the 4th, y to the 8th. And now we multiply them. We get 162. That would be x to the 5th, y to the 8th. That's the result. Any questions there? Okay. What if I have a negative exponent? What do you do with a negative 8 there? See a negative exponent, bring it to the top, right? You see a negative exponent, move it to where it's not. So the 10 over 15 reduces to 2 over 3. And y squared times y to the 8th will give you a y to the 10th. You may be asked to solve an inequality or an equation, and hopefully that one will be good review for you. Hopefully you'll feel confident, like, hey, I'm definitely going to get that one correct. We distribute the negative, we get a negative 3 plus x plus 2 is greater or equal to 2x minus 4. It's back at the heart of algebra that you loved so dearly, doing 180 problems like this in a given week. Miss Kruger's class, right? Remember? Negative 3 and 2 make negative 1, so we have x minus 1 is greater or equal to 2x minus 4. I'm going to gather my x's on the left-hand side, so I'm going to subtract 2x. I have negative x minus 1 is greater or equal to negative 4. Add my 1, and I have negative x is greater or equal to negative 3. So now what? Multiply by a negative 1 or divide by a negative 1. And when you do, you need to. So x is less than or equal to 3. When you graph that, simply plot the 3, open or close circle. Close circle, arrow goes off to the left-hand side. So suppose you get a problem like this one on the ACT where they give you a bunch of fractions. What could you do to get rid of the fractions? What do 2, 3, and 5 all multiply to? So multiply through by 30 and make it an easier fraction, or easier inequality. 30 times 2 is 60, divided by 3 is 20, so you start with a 20x. 30 times 1/2 is 15. 30 times 4 is 120. And then 30x over 5, 30 divided by 5 is 6, so we get minus 6x. Question? You all pass? Thank you. And there we go. So you should have 26x is less than 105, so you divide by 26, x is less than 105 over 26. You plot that, would it be an open or closed circle? Open circle. I promise you're going to have a question about linear functions and determining intercepts and slope. See if you can determine the x-intercept, the y-intercept, and the slope of this linear function. Go. Everybody look at it so we can determine the interesting pieces. I want you to know that the x-intercept, there's multiple ways to look at it. Everybody knows how to turn a slope-intercept form, so you know that the slope is in fact 3/2. You know the y-intercept is -3. I hope we all got that. Okay, then the next piece that we have to ask ourselves is what about the x-intercept? It's very easy at this point, folks, to determine the x and y-intercept. Look, what would you plug in for x to make 6? 3 times 2. What would you plug in for y to make 6? You plug in -3. So this is in standard form. It's easy to determine intercepts there. So, you know, if you get that question on a test, try to do it quickly. Suppose you wanted to write an equation for the line that was parallel to y is equal to 3/2 x minus 2. That passed through 6, -2. In order to write an equation for a line, you need both the slope and a point that exists on the line. You know that the point is 6, -2. If it's parallel to that line, how do slopes of parallel lines compare? They're the same, so therefore the slope for this line is going to be 3/2 as well. Do you remember our formula we use for finding a equation for a line? Y minus y1 equals 1 times x minus x1. And so you have y what? It's going to be y plus 2 is equal to m, which is 3/2 times x minus 6. So y plus 2 is equal to 3/2 x. 3 times 6 is 18. 18 divided by 2 is 9. And then we will subtract 2 and we get y is equal to 3/2 x minus 11. 2 more problems we're going to do together, and we'll pause for the day. Equation for the line perpendicular. Well, it goes through 6, -2. If it's perpendicular, what's going to be the slope? -2/3, the opposite reciprocal. Thank you. Probably going to have a question like that. Look at this graph. What is the y-intercept of this graph? The y-intercept. What is the x-intercept? Here to estimate. 4.5? Suppose we were to find the slope. We could simply just look at the rise and the run between those 2 points. The rise and the run, looks like the rise is -2, and it looks like the run is 3. So if it wants an equation for a line, we simply just take y is equal to your slope, -2/3, times x, plus the y-intercept, which is 3.